Hello everyone. Today we are going to talk about equations. This section is very long in our book, so I'm going to split it into two parts. So first, what is equation? Equation is something which has equal sign, a statement with equal sign. For example, the simplest one is 1 plus 1 equals 2, right? So this is a true equation. 1 plus 1 is actually equals 2. Sometimes equations are going to have a variable, something like this. For example, sorry, scrolled it a little bit. Let me do it smaller. 1 plus 1, that's too big. Okay, 1 plus 1 equals 2. Sometimes equations are going to have a variable like x. X plus 1 equals 2. Variable means that we don't know actually what is value of x, but we are searching for a solution. Solution of equation is a value of x, which is turning this equation into a true statement. For example, if I set up x equals 2 and then plug it into equation, I'm going to have 2 plus 1 equals 2. Is it a true statement? No, it's not a true statement. So 2 is not a solution, not a solution. How about, well, let's compare these two equations. Looks like solution is going to be x equals 1, right? Let's check. We plug in 1 plus 1, and we are going to get 2. True. Sorry, missing R. True. So x equals 1 is a solution. Sometimes we're going to be more than one solution. Sometimes even we are going to have infinitely many solutions. What operations we can use to solve equations besides guessing? Like we compare this equation number 1 and equation number 2, and we see if 1 plus 1 equals 2, then x plus 1 equals 2 means that x is supposed to be 1, right? Besides guessing, we can use next operations. We can use to solve equations. Well, there are not too many of them. Let's write them down. So if you have an equation, A equals B, and A, B are not just numbers, they are statements. Like it can be like 2 plus x plus 5 or x squared or something. So it's just like statement on the left and statement on the right. Then you can add a same expression on the right and on the left on this equation. So I'm adding on the left and adding same expression on the right. So same expression on the left and on the right. It can be a number, it can be a whole expression like 2x, for example, but it's supposed to be same on both sides. This way, it's not going to change equation, okay? Second operation, again, if you have an equation, what else we can do? We can multiply equation by a same number on the left and on the right. I'm using same letter C, but here we do have a restriction on C. C is not supposed to be equal to 0, because if you multiply it by 0, you are going to get a true statement forever, because anything multiplied by 0 is going to give you 0, and left side 0 and right side 0 is always true, no matter what was actually A and B. I'm sorry, I was supposed to write down B over here. Somehow, second time I'm writing down A. That's not supposed to happen. Well, I mean, that statement A plus B is supposed to be kind of transformed into statement A plus C and B plus C, and here also A and B. Okay, so we're going to start considering linear equations. Let me scroll it a little bit up. And number 1, linear equations. Well, usually, guys, linear equations can be brought to the form ax plus b equals 0, where x is unknown. and A and B are just real numbers. Well, a simple example of a linear equation, example number 1 is, for example, 7x minus 4 equals 3x plus 8. It does not look like linear equation yet, right? Because it has too many x's, too many numbers, but we always can simplify it and bring it to the form of linear equation. It is important to understand that in linear equation, x is in the first power. What I'm going to do to this equation to kind of bring it to the form of linear equation or to solve it. First, I'm going to subtract 3x from both sides of my equation. What I'm going to get if I do this? Well, over here, I'm going to have 7x minus 3x is going to give me 4x. I'm keeping minus 4. Here, 3x minus 3x is 0, so equals to 8. Now I see that I can actually subtract 8 from both sides of the equation, 8 here and 8 here. So I'm doing operation number 1. And I'm going to get 4x and minus 4 and minus 8 is minus 12 equals to 0 because 8 and minus 8 equals to 0. Well, what should I do next? How should I solve this equation next? Well, first you see that it's a linear equation. Doesn't matter that it looked a little bit different in the beginning, but we brought it to the form of linear equation. Well, actually, I would say that's not necessary to always bring it to this form. The idea is to separate unknowns on one side of equation and numbers or everything what is known on another side of equation. Can be left or right side, but they are supposed to sit on different sides of equal sign. So what I'm going to do next to solve it, because my goal is to find x, I'm going to add 12 to both sides of this equation. And I'm going to get over here 4x because minus 12 and plus 12 is 0 and 12 over here. 0 plus 12 is 12. Now I'm going to multiply both sides of this equation by 1 over 4. By 1 over 4. Yeah, guys, and you can also just divide by 4 because it's kind of going to be the same, but I'm trying to bring it to the rules we defined in the beginning. This is multiplication rule, right? 4 multiplied by 1 over 4 is just going to give me x, and 12 divided over 4, which is like 12 over 4, is going to give me 3. So my solution is x equals 3. Well, sometimes makes sense to check if your equation is working, and sometimes it's not necessary. For linear equation, usually it's not going to be necessary, but let's do the check. So you just plug in solution into your equation and check if equation is becoming a true statement. So I have 7 multiplied by 3 instead of x minus 4 equals 3 multiplied by 3 plus 8. Well, if I simplify this, that's 21 minus 4, which is going to give me what? 17. And on my right side, I have 9 plus 8, which is also 17. So it's actual solution. Okay, how else linear equations can look? They can look like a formula, and somebody will ask you to solve a formula. Example number 2, solving formulas. For example, what kind of formula we can solve? For example, you know, the formula for a volume of a box is A multiplied by B multiplied by C. If you have a box with dimensions A, B, and C, for example, this is A and this is B and this dimension is C, like 3 dimensions are given. To find the volume of this box is to multiply all dimensions, right? Now somebody is asking, can you find actually side A if volume is given and B and C are given? So let's form it into math question. Solve for A. Solve for A. Okay, how do we solve for A? We're going to take our formula now, has no numbers, right? Our unknown is going to be A. So we kind of think that A is our X. So to solve for A is to isolate A without any other coefficients. For example, here A has coefficients B and C. So I'm going to multiply, or I would say better, divide by B and divide by C, both sides of this equation. And remember, canceling in the fraction, I can cancel B, B, and C, and I'm going to get that A equals volume divided over B multiplied by C. Formulas can be a little bit more complicated, but generally speaking, that's how we deal with the formulas. Okay. Now, guys, we are kind of done with linear equations about a variable in the first power. We are going to move to quadratic equations. Let me scroll up. So quadratic equations, number 2, quadratic equations. Well, what are quadratic equations? Quadratic equations in the general form are going to look like this: ax squared plus bx plus c equals 0. So the difference between linear and quadratic is that it's going to have an extra term, x squared. Here, x is unknown, and a, b, and c real numbers. I think I'm missing one more. Numbers, and a is not equal to 0. If a is equal to 0 in this equation, it's becoming a linear equation, which we already considered, right? Well, how do we solve quadratic equations? There are many different ways of solving quadratic equations, and I'm going to show you a couple of ways. For example, way number 1 is to use zero product property. I'm going to label it 1. Use zero product property. What is this property telling us? This property tells us that if you have a product of two expressions equals to 0, then to make it equal to 0, the only one or any of these two can be equal to 0. Either A equals to 0 or B equals to 0. How it's going to work for us? Well, for example, somebody gives us equation. X minus 1, x plus 2 equals 0. How do we know that this is a quadratic equation? Well, if we open this parenthesis, we are going to get x multiplied by x, right? Plus x multiplied by 2 minus x multiplied by 1 and minus 1 multiplied by 2. If we simplify this, we are going to get x squared. These two are going to be combined. 2x minus 1x is plus x, and minus 2. And we got a classical quadratic equation. My a is equal to 1, my b is equal to 1, and c equals minus 2. But, well, somebody makes us a present. It represents equation as a product of two expressions. Well, if you have equation represented as a product, you can use a zero product property. So if the product is equal to 0, either first factor or second are equal to 0. So how we are going to write it down? So we are going to write down either x minus 1 equals to 0 or x plus 2 equals to 0. Well, what happens when x minus 1 equals to 0? Well, then x equals 1, and here x equals minus 2. So we have two solutions, and solutions are, I'm going to write down x belongs, and the set 1 minus 2. So actually x can be either 1 or this one or this one, right? We are using curly brackets to show it's a set. It's not an interval. For interval, you are using normal parentheses or square brackets. Okay. Now the question is, but what are we going to do if somebody gives us not factored form, but this one? Can we kind of think of how to turn it into factored form? Yeah, guys. Let's do some theory on factoring, because to use zero product property, we will need to factor quadratic equation first. So factoring. First, a little bit of theory. Imagine that we have x plus a, like we have over here, and x plus b. just the numbers, equals to 0. What kind of equation we are going to have in this case? So instead of -1 and 2, I put just general letters A and B. Well, if we do multiplication, we are going to have x by x plus x by b plus a by x and plus a multiplied by b. If we simplify this expression, we are going to get x squared plus a plus b x. Simplifying these two terms, right? The same factor x outside and b and a are inside of parentheses, plus a multiplied by b. What does it mean for us? If we compare it to the equation we have, x squared plus x minus 2, we're going to see that if this equation was factored, I put it like long gaps between like plus and x to show that there is supposed to be a coefficient. Actually, coefficient here is equal to 1, right? We do see that a plus b, if they were two numbers added to x in a factored form, they are going to make a sum of equals to 1. So a plus b must be equal to 1. On the other hand, a multiplied by b supposed to be equal to -2. Now we have to think up about two numbers which are making up a product of -2 and the sum of, well, that's a little bit strange. I have this thingy, the shadow. A plus b equals 1, sorry, a multiplied by b equals -2. So think about two numbers which are going to satisfy this. Well, first, what are like factors of -2? -2 can be represented as -1 by 2 or as -2 by 1. Let's check if sum of either these two or these two are going to give us 1. Well, let's add -2 and 1. Doesn't work, right? -2 and 1, the sum is going to be -2 plus 1 equals -1. But -1 plus 2 will be equal to 1. So check, works for us. So we can say that A equals, for example, -1 and B equals 2. Here, it's not going to be important which one is equal to which because you can always switch the factors. So you can say that A equals -1 and B equals 2, and then write down in a factored form your expression. Okay, so that's how we solve by factoring. Maybe we should do one example because just to make sure that everyone understands this. So example number 2. Well, let's have x squared minus 2x minus 3 equals 0. So if you want to factor it as x minus a or plus a and x plus b, what kind of factors we can get over here? Well, we remember that a plus b must be equal -2, right? That's a sum of two numbers. And a multiplied by b must be equal -3. Well, we are lucky there are not too many products which are giving -3, right? It's -3 by 1 or -1 by 3. So which one is going to give us -2? Well, let's just add up. 1 minus 3. That's -2. 1 minus 3 equals -2. So we are going to set up a equals -3 and b equals 1. And our factored form in this case is going to be x minus 3. Well, it's supposed to be plus a, but because a is -3, we're going to have -3 plus 1 equals to 0. Now we can solve this equation using 0 property. We can write down that x minus 3 equals to 0, which gives us x equals 3, and x plus 1 equals to 0, which gives us what? X equals -1. We subtract 1 from both sides. So our solution in this case is 3. I'm going to write down x first. X belongs, and it's -1 and 3. Okay, so kind of not very difficult to solve, right? Last type we are going to do in today's lecture is solving a perfect square. And the next lecture is going to be about quadratic formula. So example, well, how do we label it actually? Factoring, okay, perfect square. Using a perfect square property. For example, guys, if you have equation x squared equals 25, you can easily extract the square root of both sides and get x equals plus minus square root of 25, right, which is 5. So in this case, we have two solutions, x1 equals 5 and x2 equals minus 5, right? What if our expression in parentheses is a little bit more complicated? Example number 1 again. What if we have x minus 1 squared equals 25? How are we going to solve this one? A more complicated version. Well, we're still going to extract the square root. X minus 1 equals plus minus. And the square root of 25 is 5, right? We extract the square root of both sides. The square root here and square root here. Well, I'm going to write it on square root, right? Now, plus minus 5 means that x minus 1 can be equal plus 5, or x minus 1 can be equal minus 5. Now, what are we going to do? We are going to solve these two equations separately. So we're going to add 1 to both sides here and get x equals what? X equals 6. Or we are going to add 1 to both cases here and get minus 5 plus 1 equals negative 4. So our solutions in this case, negative 4 and 6. Right? So that's how we kind of use quadratic property, perfect square. Now, usually, guys, equation is not going to look like a perfect square. Somebody is going to give you an equation looking like a standard form, and they say, okay, can you complete the square and use the property of perfect square to solve it? Let's see how it can look in real life. Example 2. So equation looks like this, x squared plus 4x minus 5 equals 0. And we are going to complete the square first. Well, how do we complete the square? We are expecting perfect square here, right? So we know that, well, the perfect square formula in this case, let me just scroll it up. Perfect square formula is a plus b squared equals a squared plus 2ab plus b squared, right? So we need 3 terms. And my a is already kind of known because that's x squared, a is going to be x, right? And then if this a is x, then 4 is going to make up 2b, right? 2b equals 4, from where we can make a conclusion that b equals 4 over 2. So I'm going to have plus 4x. According to the formula, I'll need a b squared. 4 over 2 is 2, so I'll need a 4 here, plus 4. When you add 4 to equation, you will need to compensate it, either adding it to the right side of equation or subtracting from the left. I'm going to add it to the right side of equation. So I'm kind of adding 4 on both sides. Now I'm going to kind of make up a perfect square over here. This one is going to make a perfect square. Let me move to the right. So it's x plus 2 perfect square. Right, minus 5 is going to be minus 5, and 4 is going to stay as 4. It's not yet the square equals to a number equation, right? To make it into this type, I'll need to move 5 to the right. So I'm going to add 5 to both sides and get x plus 2 squared equals 9. Now I'm going to extract the square root of both sides, the square root here and square root here. So what I'm going to have, x plus 2 here, and the square root of 9 is plus minus 3, which is going to give me 2 equations. X plus 2 equals 3, or x plus 2 equals negative 3. Now I'm just going to solve them. Subtracting 2 on both sides is going to give me 3 minus 2 equals 1. And again, subtracting 2 on both sides is x equals -3 minus 2, -5. So we have two solutions again, and solutions are 1 and -5. So x belongs to this set of numbers. Okay, I think what I'm going to do, guys, I'm going to finish my first part at this point because I don't want to make very, very long lecture. And we are not done with section yet. We're still going to have more equations to consider. We even did not kind of consider quadratic formula. That's just the first part. Okay, and I'll see you like in the second part of the lecture. Okay, thank you.